If both drive wheels on a forklift were locked together and forced to rotate at the same speed, turning would be a problem. The tires would drag across the floor, steering would feel heavy, and over time, this would cause excessive tire wear and stress on the axle. But forklifts turn smoothly, even in tight warehouse spaces and even while carrying heavy loads. That smooth turning is made possible by a component inside the drive axle called the differential. Hello everyone, welcome back to Lift Parts Warehouse channel. In this video, we're going to break down how a forklift differential works clearly, what's happening inside the gears, and how it allows the wheels to rotate at different speeds without losing power. The differential is a gear system located inside the drive axle. Its job is to take power coming from the engine and split it between the two drive wheels. But it does more than just split power. It also allows each wheel to rotate at a different speed when needed. This is important because in real-world operation, both wheels do not always need to rotate at the same speed, especially during turning. Let's understand this with a simple situation. When the forklift moves straight forward, both wheels travel the same distance. As a result, both wheels rotate at the same speed, and everything works smoothly. Now imagine the forklift taking a turn. The outer wheel, the one on the outside of the turn, has to travel a longer path. At the same time, the inner wheel travels a shorter path. Now both wheels are still connected to the same axle and receiving power from the same source, but physically they need to rotate at different speeds to match the distance they are traveling. If both wheels were forced to rotate at the same speed, one of them would have to slip against the ground. That slipping causes tire wear, reduces efficiency, and makes steering harder. This is exactly the problem that differential solves. In a forklift, the differential sits inside the drive axle housing, between the two drive wheels. Power from the engine flows through the transmission and into the drive shaft. The drive shaft connects directly to the differential, which then distributes that power to both wheels. So everything that happens inside the differential directly affects how the wheels rotate. To understand how it works, let's go through the main parts. Power first enters through the pinion gear. The pinion gear is connected to the drive shaft and spins as the engine sends power. This pinion gear drives a larger gear called the ring gear. Because the ring gear is larger, it also reduces speed and increases torque, which is important for moving loads. The ring gear is attached to a rotating housing called the differential carrier. Inside this carrier are the spider gears. These spider gears are small gears that can rotate in two ways. They rotate with the carrier and can also spin on their own axis. The spider gears are connected to two side gears. Each side gear is connected to an axle shaft, and each axle shaft connects to a wheel. So when power flows through the system, it ultimately reaches the wheels through these gears. Now, let's look at how all of this works when the forklift is moving straight. In this condition, both wheels are experiencing equal resistance from the ground. There is no need for a speed difference between the wheels. As the ring gear rotates, it turns the carrier. The spider gears move along with the carrier, but they do not spin on their own axis. They act like fixed connectors between the two side gears. Because of this, both side gears are pushed equally. This means both axle shafts and both wheels rotate at the same speed. So during straight movement, the differential behaves almost like a solid axle. Now let's look at what happens when the forklift starts to turn. As the forklift turns, the outer wheel needs to rotate faster, and the inner wheel needs to rotate slower. This creates a difference in resistance between the two wheels. The inner wheel resists more because it travels a shorter distance. The outer wheel needs more speed because it travels farther. This difference is what activates the differential. Now the spider gears begin to spin on their own axis. This is the most important part to understand. The spider gears are now performing two motions simultaneously. First, they are rotating with the carrier, just like before. Second, they are spinning on their own axis. This spinning action changes how they interact with the side gears. On one side, the spinning spider gear adds speed to the side gear. On the other hand, it reduces speed. So instead of both side gears rotating at the same rate, one speeds up while the other slows down. This allows the outer wheel to rotate faster and the inner wheel to rotate slower. All of this happens smoothly and automatically without interrupting power flow. The differential does not randomly send power to one wheel. Instead, it allows a speed difference while still transmitting torque. You can think of it like this. The total movement is shared between both wheels. If one wheel rotates faster, the other rotates slower to balance it out. In forklifts, this system is especially important. Forklifts operate in tight spaces and make frequent turns. Without a differential, turning would cause constant tire drag and increase wear. Also, forklifts often carry heavy loads. When turning with a load, the weight shifts between the wheels. The differential allows each wheel to adjust its speed naturally in response to resistance, helping maintain control and stability. Limitations of an open differential. Most forklifts use an open differential. While it works well in normal conditions, it has a limitation. If one wheel loses traction, such as on a slippery surface, it becomes easier for that wheel to spin. Since the differential follows the path of least resistance, more motion goes to that wheel. This can reduce effective traction and make it harder for the forklift to move. If the differential is worn or damaged, you may notice whining or grinding noise from the axle, uneven tire wear, difficulty during turns, vibration while driving. These signs usually indicate worn gears, insufficient lubrication, or internal damage. The differential is a key part of the forklift drive system. It allows smooth turning, protects tires from unnecessary wear, and ensures proper movement under load. Understanding how it works helps in diagnosing issues and maintaining performance. At Lift Parts Warehouse, we supply differential components, axle parts, and drivetrain replacements for a wide range of forklifts. Using the right parts and maintaining proper lubrication is essential for long-term reliability. Thanks for watching, and we'll see you in the next one.